Hi all, now we are going to discuss about the scales. So in engineering drawing also is an important topic, how to draw the scales, different types of scales, which are the practice for when you are drawing the complex figures or objects. So now we discuss about the scales. So here just see, in engineering drawing the scales are practiced when there is a difficulty of drawing very large diagrams and very small diagrams. So here the difficulty means very large diagrams. So very large means we will be representing the diagrams on a drawing sheet when the size of the object is more than the drawing sheet. In that case we face the difficulty to how to represent that diagram on a particular drawing sheet. So when it is very small, that means if the dimensions are too small, we cannot see the exact shape of the object also on a drawing sheet. So these are the difficult situations that we may face while drawing the large figures or small figures on a drawing sheet. So in that case we choose the scales. Okay, so here again when the thing see the next point, when the things are very large that we cannot draw on a drawing sheet, then we reduce the dimensions with a particular standard ratio. That ratio is called here representative factor, that is RF, and the scale is called as reduced scale. So here just now I said when the figure is very large we cannot draw on a drawing sheet. So in that case what we have to do, we need to reduce the dimension of a object at a particular scale, at a particular standard ratio. By using standard ratio we need to reduce the dimensions of a object, then we need to go for drawing that figure on a drawing sheet. So here that ratio is called as the representative factor, that is represented by RF. Okay, and here the scale is reduced scale. By why means we are reducing the dimensions for drawing the larger object on a drawing sheet. So the scale is called here reduced scale. Okay, and next thing, when the things are too small that we cannot draw on a drawing sheet, then we enlarge the dimensions with a particular standard ratio. That ratio here also called as representative factor. That scale is called as enlarged scale. So here the second case is when the object is very small that we cannot see the object shape exactly on a drawing sheet. In that case we need to enlarge the dimensions by using certain proportionality. So that proportionality is called as here the standard ratio. Okay, by using a standard ratio we need to enlarge the dimensions of the object for exact view of the small object. Okay, so here that ratio is again here called as the representative factor, and here the scale is called as the enlarged scale. Okay, certain standard ratio will be using, that ratio is called always representative factor, and what is the scale we have used means we need to say that enlarged scale. Okay, when the size of the object is small we will be using the enlarged scale according to the representative factor, and again when the object is very large we use the reduced scale, and that is obtained based upon the standard ratio, that is the representative factor. Okay, and next here the formula for the representative factor. Here the formula for the representative factor is equal to the dimension on a drawing by actual dimension of the object. Dimension on a drawing means here if dimension on a drawing will be very small, when you go for the larger object, so the dimension of the object on a drawing sheet will be small. So whatever the small value you are considering, that value is the dimension on a drawing, and the actual dimension of the object means that is the actual dimension means that is the large dimension of the object that we cannot represent on a drawing sheet. So based upon that whatever the values we are considering, okay, from that we need to find out the representative factor, that is dimension on drawing by actual dimension of the object. There are some more formulas in the problems they will mention for getting the representative factor. How they will be means here these are the two formulas. For finding the representative factor in a problem, he'll give certain information in terms of area, in terms of volume. Okay, so certain area, that means 1 square meter is represented by 2 square meters, or 2 square meters is represented by 1 square meter. Okay, that means 2 square meter is represented by means 2 square meter is the actual, and represented by 1 square meter means that is the dimension on the drawing. Okay, like that he will give certain relation. So how will you find out the representative factor in that cases means these are the two formulas. Okay, area as per drawing by actual area, and similarly in terms of volume he has given, then the formula is 3 root of volume as per drawing by actual volume. Okay, in terms of area and volume. If the representative factor is given, information is given for finding the representative factor. Like this, by using these two formulas, we need to find out the RF value. Remember, in terms of area, square root of area as per drawing by actual area, and similarly 3rd root of volume as per drawing by actual value. Okay, so these are the formulas represent. Remember. So next we go for another one. So here the example. The example means whatever I have discussed, how we are using the scales, how we are getting the representative factor. So to understand, this is the example. So listen carefully. For example, if you want to draw a line of 1000 mm, it means 1 meter long. You can't draw it on a drawing sheet. That means automatically we can say, so 1000 mm means 1 meter. The drawing sheet will be around it will be around A3 sheet, means around 400 mm, like that the length. So here the 1000 mm means it is more than 400 mm. So in that case we cannot represent the line or whatever it may be. An object is consisting of a line of 1000 mm. We cannot represent on the drawing sheet. So what we are going to do for representing that 1 meter line on a drawing sheet means, here for that we assume that we draw the 1000 mm line as 100 mm line, okay, on a drawing sheet. So that means 1000 mm line we represent, we draw on a drawing sheet by using 100 mm dimension, and we represent that dimension as a 1000 mm. That means here every time if you want to draw the length of 1000 mm, that is 1 meter line, we need to draw a line of 100 mm of length. Okay, so like that, every time we represent the 1 meter line as a 100 mm line. Okay, so that is the proportionality here. And similarly, if the same drawing, that means if the same figure consists of 100 mm of another line, that means if the length of the another line is 100 mm, in place of that 800 mm we have to draw 80 mm. How the 80 mm is obtained means, based upon the first dimension proportionality we have considered. That means here we have considered 1000 mm should be drawn by using the 100 mm. Similarly, 100 mm should be drawn with using 80 mm. That means there is a certain proportionality ratio we are considering. Okay, so by using that we convert all the dimensions of a particular object which is having more dimensions, then we draw the actual figure diagram. So how it means, by using a representative factor. So by this assumption, how can we find out the representative factor? Now I show you. So here this is the representative factor formula. Already we have discussed the formula. So the formula is dimension on drawing by actual dimension of the object. So here the dimension of drawing we have considered 100 mm. Okay, actual dimension is 1000 mm. So by this we can get a certain representative factor. Okay, so dimension on drawing is 100 and actual dimension is 1000. So we got a representative factor, that is the ratio 0.1. Okay, so here by using 0.1 we need to multiply this to all dimension of the larger object, then we get the reduced dimensions. Okay, so those can be representable on a drawing sheet. So like this we need to find out the representative factor for reducing the larger dimensions as per a particular ratio. Okay, this ratio we need to apply to all the dimensions of a large object, then we can be able to draw the diagram of a particular object. Okay, so this is the way of finding the representative factor. So this is an example, for your understanding purpose I have explained. Okay, how the problem will be given, so we discuss next. Okay, so here before that we have to know what are the types of scales we are going to learn in scales topic. So there are different types of the scales are there for practice. So they are plane scales, diagonal scales, vernier scales, comparative scales, scale of chords. Okay, these 4 are to represent the lengths only, and this 5 is for representing the angle. Okay, so about these various types of scales we discuss in next session. So first we are going to discuss about the plane scales. Okay, so before again the explanation of the scales, we have to recollect the mathematical relations. Already we know, but once again remember, 1 kilometer is equal to 10 hectometers, 1 hectometer is equal to 10 decameters, 1 decameter equal to 10 meters, and similarly 1 meter is equal to 10 decimeters, 1 decimeter is equal to 10 centimeters, 1 centimeter is equal to 10 millimeters. Okay, so these already we know, but while drawing the scales, the problem will be given in these terms. So by using these terms we need to represent the given particular length on a scale. Okay, remember all these relation. So okay, so this is the introduction to scales. So in next video we are going to discuss how to draw a plane scale. Okay, based upon the problem given, we discuss about the plane scales. Okay, here I hope you understand about the introduction to the scales. So even if you don't understand, please watch the next video, then automatically you can understand what do you mean by a scale. Okay, so based upon the problem we can easily understand what do you mean by scale and why you are practicing the scales. uh, thank you for watching my video, and don't forget to subscribe to my channel. And if you have any doubts, please give a comment and I'll try to clarify your doubts. Thank you all. Thank you so much.